Hello everyone, welcome back to Diksha Karnataka YouTube channel. Today is 31st of December, that is the last day of the year, and tomorrow onwards will be new year. So I wish you all a happy new year in advance. And today in the PU2 Brahmastra series I am going to discuss the magnetism and matter chapter. So many of you have requested it earlier, but due to the constraints, time constraint, I was not able to give you in the past, but right now I will give you this chapter, and this is a medium important chapter. So what all we can expect from this chapter, we will see that in a while. And let's start with the schedule. So this week, tomorrow will be a holiday, 1st January, so no classes will be there, and all the classes numbers may be slightly jumbled up. So I am only giving you that today will be magnetism and matter, and Friday I will complete the all 14 chapters of physics by completing EMOF's chapter. So EMOF's chapter will be completed. So all 14 chapters will be completed by Friday. So that is guarantee. Okay, some other chapters, some other numbers may be slightly jumbled up, but this is for sure that today is day 44. Magnetism and matter is going live, and on Friday we will be doing the last chapter, EM waves. Other than that, slightly other teachers, whenever they are taking classes, they will update accordingly. Okay, now as you know that currently we have launched our PU2 success blueprint test series, and everything is available for just $599, and there is a surprise new year celebrations is going on. So if you add my personal coupon code SAM100, you will get additional 100 rupees off. So entire price will be only $499 if you add my personal coupon code SAM100. That is special for new year. Okay, so the Christmas offer is ended, now new year offer is going on, and if you add my coupon code SAM100, you will get additional 100 rupees off, right? And what you will get, 12 mock tests. Out of that, 3 of them are already completed. Okay, one more part test is still there, but you will get the question paper, you will get the solutions, you will get the video solutions. Okay, other than that, 8 full length syllabus paper are yet to come. So if you want to join today and use my personal code, you will get full length question papers. You have to answer them, and then you will get the PDF solutions for the question paper, as well as the video solutions that we teachers will provide you. We will explain all the questions, all the solutions. Also, any doubts you might have while answering the question paper, all the doubts will be cleared in live session. So do not wait, join this test series today. Okay, so these are all everything you will get from this test series. Right now, let's look into the blueprint of this chapter. So in this blueprint, as you can see, blueprint 1 says that one remembering based MCQ question, one remembering based fill in the blanks question, one understanding based short answer type 3 marks question. In blueprint 2, it says again the same thing, but in short answer type questions it says remember based. Okay, though in this part, in 2 marks and 3 marks section, there is not super difference between an understanding based question and a remembering based question. Only if it is an MCQ with HOTS question mentioned, then that you can expect some slightly tricky MCQ. Otherwise, all the MCQs in this chapter are remembering based. In fact, in blueprint 3 also it is remembering based. Only difference is that blueprint 3 is giving 6 marks for this chapter, and so one remembering based question, one remembering based 2 marks question, and one remembering based 3 marks question. So as you can see, most blueprints are saying there will be one 3 marks question, and only one blueprint is saying 2 marks question. So what we will do, we will obviously solving 15 MCQs as usual, and 5 fill in the blanks. That is also usual. If there is a fill in the blanks, we are solving 5 fill in the blanks, and in this case we are solving 5 questions which can be asked as a 2 marks question, can be asked as a 3 marks question. Okay, so it our priority is to cover all the 3 marks question, but that question can come as a 2 mark question. So for example, if they ask you that what is the difference between A and B? Write 3 differences for a 3 marks question, write 2 differences for 2 mark question. So everything will be covered in this lecture. This will not be a super long lecture, but it is very effective. If you want to score 5 marks guaranteed from this chapter, minimum 5 marks you will get, maximum up to 6 marks you can get from this chapter. So follow me till the end, and if you are getting trouble to solve the MCQs, then definitely you should watch this video, right? And also, if you have not yet subscribed to our channel, don't forget to subscribe to our channel, like this video. So let's begin. When a bar magnet is suspended freely, it points in the direction of, very easy question. When a bar magnet is, and this is from one of your previous year question, when a bar magnet is suspended freely, it points in the direction of north south. Okay, north south is the answer. Next question, the ferromagnetic material among the following is, so you have to identify which is a ferromagnetic material. Okay, we know nickel, cobalt and iron, they are ferromagnetic material. So here nickel is the ferromagnetic material, copper, lead, calcium, they are not ferromagnetic material, right? So easy to guess. Okay, next question, the physical quantities, this is a little tricky question. The physical, and this is from your blueprint, one of the blueprint question has this question, so not super easy but not super difficult either. The physical quantities related to magnetism are listed in column 1 and column 2, and the dimensions are listed in column 2. Identify the correct match. So you have to identify, basically this type of questions you have already seen. So what I will do, I will tell you what is the unit of magnetic field. Magnetic fields unit is this mt to the power minus 2 ampere to the power minus 1. Magnetic permeability is little tricky, we will leave that. Magnetic moment is L square A. Okay, ampere into meter square, that is the unit of magnetic moment or the dimension of magnetic moment, and magnetic permeability whatever is left, that is option A. So option A is, so option A is matching with 2. Okay, option B is matching with 1, and option C is matching with option 2 is, B is matching with 3. Okay, and this is matching with 1. So what is the correct answer? Correct answer is 1C, 2A, 3B. 1C, 1C, 2A and 3B. So this is the correct match, right? So you have to identify them, write them in the column next to it, and then you have to find the answer, right? Easy, not so difficult. Now next question, this is a statement based question. The net magnetic flux through any closed surface is 0. Yes, the net magnetic flux through any closed surface is 0, that is we know Gauss's law of magnetism. The number of magnetic field lines leaving the surface is balanced by number of field lines entering it. So if the surface is closed, the number of lines that is entering it, the same number of lines will exit. That's why the net magnetic flux is 0. Okay, net magnetic flux 0 does not imply that there is no magnetic field. The magnetic field is there, but total number of incoming field is exactly the total number of exiting field. So both statements 1 and 2 are correct, and 2 is the correct explanation for 1. Yes, this is the correct explanation. There are other possible explanations are also there, but this is also a correct explanation. Okay, one of the other explanation is that there is no magnetic monopole. Okay, there is no magnetic monopole, thus magnetic field lines always closed. Okay, magnetic field lines are always closed loops. There is no magnetic monopole, and along with this also they all explain the correct statement for this. Okay, they are all actually linked. This statement too, I said magnetic, there is no magnetic monopole. Because there is no magnetic monopole, the number of field lines entering should be balanced by the number of field lines exiting, right? So they are all linked. So that's why as I said, statement 1 and statement 2 are correct, and they this is correctly explaining the statement 1. The SI unit of magnetic flux is very interesting. SI unit of magnetic flux is Weber. Okay, it is Tesla meter square, also called Weber. Okay, So in the past there was a tendency that any unit, any new quantity you discover or even any new quantity you define, you name it with some scientist, some physicist who is involved in this field. So Weber was one of the physicists who did some calculation, some explanation in magnetism. So the unit of magnetic flask was denoted by Weber. Okay, but in modern units we sometimes use Tesla meter square. Tesla meter square is same as Weber. Okay, don't fall for the trap. It is not Tesla per meter square. It is Tesla meter square. Next is universal property among all substances. This is an interesting question. It came in 2024, this year March exam. Okay, universal property, this year saying because this is the last year. From tomorrow onwards, new year will start. Your exam year will begin, right? So universal property among all the substances is diamagnetism. Very interesting. Okay, it is mentioned in your book in a small way that all the properties, among all the properties, diamagnetism is the most common. It is present in all the materials. Okay, it is getting overshadowed by paramagnetism and ferromagnetism. Okay, there is a separate diamagnetic material is there. Okay, that is correct. But even if the material is a paramagnetic material, even if the material is a ferromagnetic material, okay, they still have a small bit of diamagnetism in it. Okay, so diamagnetism is common, whereas paramagnetism and ferromagnetism sometimes override the diamagnetism. Okay, clear? So you have to remember, this is a remember based question, so you have to remember this answer. Magnetization of sample is, magnetization is defined by magnetic moment per unit volume. Okay, so correct answer is option C, magnetic moment per unit volume, direct from definition. The net magnetic flux through any closed surface is 0, is in accordance with Gauss's law of magnetism. This is according to the Gauss's law of magnetism, right? Not electrostatics, not electromagnetism, not Ampere circuital law. So it is actually according to Gauss's law of magnetism. Next, in a permanent magnet at room temperature, domains are partially aligned, domains are perfectly aligned, magnetic moment of each molecule is 0. The individual molecules have non-zero magnetic moment which are all perfectly aligned. Okay, so basically a permanent magnet, when it is at room temperature, domains are obviously aligned, but how they are aligned, if they are perfectly aligned, then it will be a very strong magnet. But domains domains are not perfectly aligned, they are partially aligned. Okay, in a magnet, if you are considering a room temperature is not standard temperature, so that's why domains are partially aligned, because there is some temperature effect of the temperature, right? That's why domains are not fully aligned, but they are partially aligned. Now, needles N1, N2 and N3 are made of a ferromagnetic, a paramagnetic and a diamagnetic substance respectively. So N1 is ferromagnetic, N2 is paramagnetic and N3 is diamagnetic. Okay, a magnet when brought close to them, now we are taking a magnet and you are bringing it close to them, attract all three of them? No, it only attracts paramagnet and ferromagnet. Out of that, it attracts ferromagnet quite strongly and paramagnet weakly, whereas it repels diamagnetic material, right? So attract N1 strongly, N2 weakly and repel N3 weakly. So this is the correct answer. N1 is ferromagnetic, so it is getting attracted strongly, and N2 is paramagnetic, so it is getting attracted weakly, and N3 is a diamagnetic, so it is getting repelled weakly. So this is the correct answer. You can check the other options also, but not required in this case. Next, question number 11. The susceptibility of ferromagnetic substance is. So ferromagnetic substance means strong magnets, they can produce strong magnets, so their susceptibility is very, very high. It is very, very higher than greater than 1. Okay, it is not 0, it is not greater than 1, it is not less than 1, it is very, very greater than 1. Okay, which of the following properties is false for a bar magnet? So for a bar magnet, we have to check which of them is false. Okay, very, very careful. So it does not produce magnetic field. Oh, first option itself is the answer. It obviously produces magnetic field. Bar magnet always produce magnetic field. Let's check the other options in this case because it is an interesting question. It poles cannot be separated. Yes, their poles cannot be separated. Correct point. It points north south direction when suspended. Yes, that is also correct. It points north south direction when suspended. It is like its like poles repel and unlike poles attract. Yes, like poles repel and unlike pole attracts. That is a property for charges also. Unlike charges attract, like charges repel. So same thing is here. So only correct correct answer for this question will be option A, which is a false statement. Okay. So this is a slightly confusing for you maybe, but you have to identify, okay, this is the wrong statement. We have to mark the wrong statement, not the correct statements. There should be 3 correct statements, only 1 wrong statement. That's why student gets confused even though the question is very, very simple. Next, a susceptibility of certain magnetic material is 400. What is the class of this magnetic material? Susceptibility, as we have learned, that is very, very high for ferromagnet. For paramagnet it is slightly greater than 1, for diamagnet it is slightly less than 1. So definitely this is a ferromagnetic material. The magnetic field lines inside a bar magnet are from north pole to south pole, are from south pole to north pole, does not exist, do not exist, exist only when external fields are present. So let's see, we have a bar magnet. It is a north pole, it is a south pole. So we know that outside the magnet field lines runs from north to south. Okay. So in outside the magnet the field lines runs from north pole to south pole, but inside the magnet it runs from south pole to north pole, right. That is why magnetic field lines are closed loop. So they are closed loop. There is no gap in between, unlike the charges. In case of charges they do not start travel in the opposite direction, right, but in case of magnetism they do travel in the opposite direction. So that is why inside the magnet magnetic field lines travel from south pole to north pole. So they are from south pole to north pole. Okay, be careful, they have said inside a bar magnet. Inside a bar magnet means what happens inside, not outside, right. Next question, when a bar magnet of dipole moment M is placed in an uniform magnetic field B, the torque is what is the expression for torque? So torque is M cross B. Okay, the torque is M cross B. It is not B cross M or minus M cross B or M dot B, not dot product, obviously, because torque is a scalar quantity. So definitely it is a vector quantity. Dot product is a scalar quantity, but torque is a vector quantity. So definitely it will be a vector quantity, and only answer is M cross B, not the negative. In fact, if you see, these two are actually same. Okay, definitely these are not the answer. Now next is fill in the blanks. So we have completed all the MCQs. Now let's discuss about fill in the blanks. The magnetic susceptibility of a paramagnetic substance is inversely proportional to its dash. So let's check the options. Magnetic susceptibility of paramagnetic substance is inversely proportional to diamagnetic. Is it making sense? No. 0, is it making sense? No. Proportional to its 0 is not a complete sentence. Proportional to its temperature, might be yes, might be we have to put a star, maybe this is the correct answer. Next, check the next option, magnetization, maybe it is a answer. Paramagnetic, definitely not making sense. Ferromagnetic, also not making any sense. So maybe magnetization, maybe temperature. If you are sure, not sure, then check the other options. Okay, you will see here magnetic moment per unit volume is called. Magnetic moment per unit volume is called magnetization. So definitely this answer will be temperature. So if you are confused between two options, check all the other options where you can fit them. Okay, try to make a complete sentence. I have seen students, they answer randomly, or sometimes they are so confused. Try to make a sentence out of it if it is making any sense. So property proportional to its either temperature or magnetization. It is possible, right? Magnetization is also making a sense, also making a sentence. So, definitely magnetization can be answer, but if you see there is an option where question number 19 the answer is magnetization, there is no other correct option is possible. So, so from there we can say this must be temperature. Next question, the magnetic susceptibility is negative for dash materials. So, magnetic susceptibility is negative for diamagnetic materials, we already know that, right. So, diamagnetic is the answer, right. The net magnetic flux through any closed surface, the net magnetic flux through any closed surface is 0. Okay, so this is this answer is 0, and this answer I already explained, magnetic moment per unit volume is magnetization. Next, last option, magnetic susceptibility is slightly positive for dash material. So, magnetic susceptibility is slightly positive for paramagnetic material, not ferromagnetic. Ferromagnetic has much higher than positive. Okay, they are not slightly positive, they are highly positive. That is why this is the paramagnetic material. So, these are the type of questions that you might expect in your final exam, in your preparatory exam. So, get ready for next portion, which is 3 marks, 2 marks or 3 marks question, short answer type questions. Write any 3 differences between diamagnetic and paramagnetic materials. So, this is a 3 marks question clearly, but if they ask you write on any 2 differences between paramagnetic and diamagnetic, then the same question can be a 2 mark question as well. That is why I said there is not super difference between 2 marks and 3 marks question. This chapter is anyway very small chapter, so a very less number of questions are possible, and if you study all these questions, definitely your second PU requirement will be done. Okay. So, property magnetic behavior. Now, this style of writing is very much preferable. You can directly write from this part also, but if you want to talk to your examiner, talk to your teacher that sir, I am a good student, I have studied whole year for this exam, then you have to add this extra information so that the teacher gets impressed, and as I mentioned that you can talk through your answers to the teacher, invigilator, who even not know you. Okay, they don't know your name, they don't know anything about you, only they know about the roll number. Okay, only thing that you are allowed to write in the sheet that an examiner can view is your roll number, right. So, your roll number is only your identity, and the teacher does not know who you are. So, even if the teacher may be, even though it is not possible, even though teacher is someone known to you, okay, if you write it properly in this way, then teacher will get impressed and they will consider minor mistakes that you might make in some other future answers. So, magnetic behavior, they are weakly repelled by a magnetic field. Diamagnetic, in case of paramagnetic, they are weakly attracted by magnetic field. We already learned that through our MCQ questions. Magnetic susceptibility, have a small negative magnetic susceptibility, have a small positive magnetic susceptibility. Effect of magnetic field, induces a magnetic moment in the opposite direction of the applied field, induces a magnetic moment in the same direction as the applied field. Okay, but this induces, both are in weakly induced magnetic field, we already know that, right. So, this is also a weakly induced magnetic field, this is also a weakly induced magnetic, but that is fine. Here induced magnetism is opposite direction, here induced magnetism in the same direction. Now, next question, mention any 3 properties of magnetic field lines. Again same suggestion, it can be a 2 mark question, it can be a 3 mark question. So, mention any 3 properties. So, if it is a 2 mark question, then they will say mention any 2 properties. What are those? Magnetic field lines of a magnet form continuous closed loops. Okay, magnetic field lines are closed loops. Magnetic field lines from a magnet form of a magnet forms closed loop, both are okay. Next is the tangent to the field line at a given point represents the direction of net magnetic field B at that point. Okay, so, if you draw the tangent to a magnetic field line, they represent the direction of the magnetic field. Next, the most common, everyone always write this point, is that the magnetic field lines do not intersect, for if they did, the direction of the magnetic field would not be unique at the point of intersection. So, magnetic field lines do not intersect, but I have seen students they try to remember them so well that they confuse between properties of electric field lines and magnetic field lines. Sometimes they write magnetic field electric field lines form closed loop, and sometimes they write magnetic field lines do not form closed loops, they are open, right, but this is not correct. Okay, you have to remember that magnetic field lines only magnetic field lines form closed loop, whereas electric field lines are open, they do not form closed loop. Okay, so this is the basic difference. Okay, so you have to remember that. Now, next question, write the three differences between diamagnetic and ferromagnetic material. So, in this case we have discussed the differences between paramagnetic diamagnetic and diamagnetic ferromagnetic. Now, your task is to prepare from these two tables, prepare the differences between paramagnetic and ferromagnetic. That might also come in your exam. I have not given it, that in this question paper, but because I am giving you two questions which are linked with each other. So, what you have to do, you have to make a single table. Okay, in there you have to write properties and diamagnetic, paramagnetic, ferromagnetic. If you write that and if you remember, if you study from there, then your entire study will be completed, right. Let us see what is the differences. Magnetic behavior, these are weakly repelled by magnetic field, these are strongly attracted by magnetic field. Magnetic susceptibility, have a small negative negative magnetic susceptibility, have a large positive magnetic susceptibility. Okay, electric effect in magnetic field, induces a magnetic moment in the opposite direction of the applied field, induces a strong magnetic moment in the same direction as the applied field. Okay, so this is only thing that you have to remember. If you are writing this for paramagnetic, then in case of paramagnetic you have to use induces a weak magnetic field in the direction of applied field, right. Now, next question, define the magnetization of a sample, how it is related to magnetic intensity. So, let us see, the magnetization M of a sample is the measure of the net magnetic moment per unit volume of the material. We have defined this definition multiple times in our MCQ, in our fill in the blanks. Now, we are discussing this in a short answer type as well. This is a very important concept, magnetization. Okay, magnetization is net magnetic moment divided by volume. Okay, you can mention a dimension L per L square ampere, that is fine. Relation to magnetic intensity is magnetization is equal to chi H. What is chi? Chi is called magnetic susceptibility. Chi is called magnetic susceptibility. Next, state and explain Gauss law in magnetism. This is also a very common question. Gauss law for magnetism is the net magnetic flux through any closed surface is 0, that is B dot ds equals to 0, integral B dot ds equals to 0. What is the significance? Significance is the magnetic monopoles do not exist, that is magnetic field lines always form closed loop. So, that is very important, that you have to mention this magnetic field lines always form closed loop and magnetic monopoles do not exist. That is why B dot ds is 0, whatever number of field lines entering a closed surface is same number of field lines exiting the closed surface. It is always true, right, because they are closed loop, right. So, this is the main thing about this chapter, and we have completed this chapter. Do not go anywhere, because I am about to explain once more about our PU2 success blueprint test series. First, let us discuss about this test series. What is this? You will get 12 mock tests in this test series. Out of the 12 mock tests, 4-part test and 8 full syllabus question papers. Okay, out of the 4 test papers, 3 are already published, 4th one will come this week, and 8 full syllabus question papers are yet to start. So, join today, and everything you will get for a price of 599 only, and if you are following my lecture and use my personal code SAM100, then everything will be available only for 499. You will get another 100 rupee discount, new year discount. And what all you will get? You will get subject cover PCM, biology and CS. Biology and CS, biology is part of part test, CS will be part from full syllabus test. Once you start full syllabus test, you will get the CS part as well. You will get the exam focused question paper, which is exactly same pattern, same blueprint as your exam. So you will be well prepared for your exam. You will get video solutions. Obviously we will give you video solutions, you will get the revision videos, also you will get all the doubt clarification by us. We will do a live session where we will discuss where you felt the question paper was difficult, or where you have find difficulty to answer questions, what could be the possible reasons. Everything we will discuss in our live doubt clearing session. So don't miss out on that, and this special code, use it and get a 499 only for 499. Right. And I wish very happy new year and successful year ahead for all my students who are following this. And if you have not yet subscribed to my channel, don't forget to subscribe to the channel and like this video. I'll be back with new videos in the next year. Okay, after a few hours the next year is coming. So I wish you new year once more. Tomorrow there will be no videos in our channel, no live videos or no recorded videos is going. So today this is my video is last, not my video is last. There will be one more video again. That was also my video for this Decode NCERT series. So wait for that, and till then, bye.